Venn diagrams. Venn diagrams are a way of representing sets. The universal set is represented by a bounding rectangle. Every element in the universal set will be within this rectangle. Sets of elements within the universal set are represented by ellipses. Some people say circles here, but strictly speaking, Venn defined it as ellipses. Consider the sets. The universal set is the numbers from 1 to 6. The set O is the odd numbers from the universal set, and the set P is the prime numbers from the universal set. So all of the numbers from 1 to 6 must appear somewhere within this rectangle. Here we have the set O, and the members of this set will appear in this ellipse. And this is the set P, and the members of this set here will appear within that one. So let's think about where 1 goes. 1 is odd, but it's not in P, so it must appear here. 2 is in P, but of course it's not odd. 3 would go in the middle. It's both odd and prime. 4 appears in neither of these sets, but it is a member of the universal set, so it's within the rectangle but outside of the 2 ellipses. If we now consider 5, 5 is both odd and prime, so must occur in this region, which is in both of the ellipses. 6 is in neither of these, so like 4, will appear outside. We can identify different regions of a Venn diagram, and we'll look at some basic ones here. This diagram indicates the set A shaded. Here we've shaded the outside of A. So that's the complement of A shaded. Everything that is not A is shaded. Here we've shaded the intersection, those elements which are both within A and within B. And here we've shaded the union, those elements which are in A, in B, or in both. There is a good method for identifying parts of a Venn diagram, and we're going to look at it here. So in this diagram, we're going to find A, intersection not B, and then we'll come over here and do not A, union B. So, for this one here, A intersection not B. So what I'm going to do, I'm going to start by shading A. And then I'm going to get a different coloured pen, and I'm going to shade not B. So not B is everything around the outside of B. It's the complement of B. Now, because we're after an intersection, we want the part of the diagram that satisfies both. In other words, I've shaded it white and I've shaded it red. And that corresponds to this part of the diagram here. So this part of the diagram is in A and not in B. Now, if we do the same sort of thing over here, not A union B, I'm going to start by shading not A. So that's the complement of A, everything around the outside of A, like so. Then I need to shade B, so that's everything inside B. It's a union. So now we're going to take everything that's shaded, whether it's shaded once or twice. So that's all of the diagram except this bit in here, the bit that was left unshaded. So let's just rub that out. So it's everything except the unshaded part here. We can also identify, if we have sets like this, these are disjoint sets. Remember, these are sets with no intersection. So for these sets, A intersection B is the empty set. We can also identify this situation where the set B is entirely within A. B is therefore a subset of A, and we can write B is a subset of A symbolically.